heard about the term SOHCAHTOA in your math classes? What does it mean? Who is Pythagoras and what role did he play in the world of math? Hey guys, welcome to SciMath, and today we are going to be going over the basics of trigonometry and what you need to know in order to succeed in it. We will be talking about the Pythagorean theorem, SOHCAHTOA, and more. So first I want to talk about what the Pythagorean theorem is, and if you kind of recognize Pythagorean and Pythagoras sound very similar, and there is a connection indeed because Pythagoras was the mathematician who came up with this theory, and so the theorem was just named after him since he created it essentially. And so Pythagorean theorem, first of all, it only applies to right triangles, and a right triangle as we know it is so first of all, we know that all triangles, any triangle, the interior angles add up to 180 degrees. And to make it a right triangle, one of the angles has to be equal to 90 degrees. That's how you know it is a right triangle. So this applies only to right triangles. Next is obviously the formula that we need to know for this. So the formula is pretty simple, and it's a formula or a theorem, either way. It's kind of like a formula because it's so simple. And so the formula is a squared plus b squared is equal to c squared. That's what the formula is. And a, b, and c in this formula just represent all the side lengths of the right triangle, but again, they do have special meanings. So for example, a and b, they just represent the sides or legs of the triangle, whereas c holds an important role. It's the hypotenuse of the triangle and the hypotenuse of the right triangle, and the hypotenuse is just the side length right in front of the 90-degree angle. That's how you know that that's the hypotenuse, because and it's very important that c is considered the hypotenuse and not one of the sides or legs of the triangle. So that's why I said they have important rules. So let's look at this in action. Let me draw a right triangle here. So this is how your basic right triangle is represented in most textbooks. This symbol right here means that it's 90 degrees. That represents a right angle. Next, this is C, like I said, hypotenuse, because this is a 90 degree and right in front of it is our hypotenuse. So it has to be C. Next, I just put this as A and B. Now remember, when you have actual numbers and values in here, it does not matter which side you consider B and A, but in most textbooks and when you're being shown this as an example, this is how typically the right triangle is drawn out. A and B are just always over there. So let's look at an example of how this Pythagorean theorem would work. So let's say this side is 3, this side is 4, and they're asking us for this hypotenuse, right? Last side. So let's just solve it for this in our formula that we wrote up here for the Pythagorean theorem. So A is our 3, so 3 squared plus 4 squared is equal to c squared. 3 squared is just 9, 3 times 3 plus 16, because 4 times 4, is equal to c squared. Next, we just add them up together. We get 25 is equal to c squared. And now, to be careful in mind that we have to find c, so we just take the square root of both sides, and the square root is the inverse of squaring a number. So the square root of 25 is 5, and so we have c. The c is 5. Now that we've found this last side, you see how the Pythagorean theorem can help us in finding side lengths here. Next, let's talk about Pythagorean triples, as that can save you a lot of time and you don't always necessarily have to solve using this Pythagorean theorem. Pythagorean triples, like 3, 4, 5, the example that we use here is one very common example, in fact, of a Pythagorean triple. So triples. So 3, 4, 5 is one of the few, but there's a lot more, and I'll just list a few here, but you're obviously free to search online and look at what other triples there are. A few other examples are 5, 12, and 13. And then there's 8, 15, and 17. Last example here, 7, 24, and 25. These triples, so you can see that the largest side is usually going to be the hypotenuse in these right triangles, the last numbers in the sets. And so that's triples, and you can obviously go and look into that more. But next I want to talk about SOHCAHTOA, and SOHCAHTOA is just an acronym, and it's also applied in right triangle trigonometry. First I want to expand on this acronym and what it means. It's just a simple way to remember sine. It's spelled like this, and on your calculator you'll see this as SIN, not SINE, but it just still represents sine. And OH in so represents opposite over hypotenuse. Next, cos, C means cosine, and in your calculator you will see this as cos, C-O-S, and the next A and H represent adjacent, and the H you might have already guessed represents the hypotenuse. Lastly, tangent is, TOA, T represents tangent, and on your calculators you will see this as, on your calculator, tangent will be represented as tan, and so OA, O and A opposite over adjacent. That's the full form of this whole acronym here that we have. Now to see this in action is how, look, what does it represent? Sine, cosine, tangent. When looking at a triangle specifically, these you can see that hypotenuse and opposite and all that represent hypotenuse. Obviously, you know that represents a side of the triangle, right triangle. So the obviously opposite and adjacent also represent the sides. Now, how do we do this? So an example of sine, cosine, and tangent in action would be if this angle here I consider theta. Theta is just a variable for an angle measure that we do not know of. So an example would be like, let's write it out here. It would be sine and theta. I'm writing it out here, but obviously the symbol that I drew here is what we typically write when doing it out by hand. Sine of theta is equal to opposite over hypotenuse. So what you would do is, in this case, like I said, so in this you would look at theta, right? And opposite means the word implies itself that you would look opposite of theta. So right in front of it is the side B, which is 4. So 4. And we're just using this example again to make it simpler. 4 over hypotenuse, we know that this triangle has a hypotenuse of 5, so over 5. Next, cosine of theta. Cosine of theta is adjacent over hypotenuse. So adjacent means the side right next to theta, and that in this case is 3. And over hypotenuse is again 5. Next, tangent of theta is opposite over hypotenuse. So opposite to theta is B, which is 4. And adjacent is 3, so 4 over 3. And that's how theta is spelled, first of all, if I forgot to mention. But that is how SOHCAHTOA works. And so this is the end of the video, guys. I hope you learned something new and feel more comfortable with Pythagorean theorem, or just learn something new in general, and appreciate all these mathematicians even who found these things for us. And as always, remember to stay curious and keep learning. If you enjoyed the video, don't forget to like, share, and subscribe. Thanks for watching.